Alright, let's take a look at this problem. Array of doubled pairs. Given an array of even length array, return true if it is possible to reorder arrays such that array 2i plus 1 is equal to 2 times array for every, for 2 times I plus 1 is equal to 2 times I every I 2 times I 2 times, so I, which let's say that I is 0. Okay, let me just copy it. So I is 0, array 1 is equal to array 0 2 times, and then same thing, but this is 3, this is 2. So the first one, so 0 is 2 times 0 1, reorder. Okay, I can reorder like that. So basically it is asking if, so I can have 1 2 1 6 for every double. So you can, so if you pair it like this, form this or that. The question is basically asking if you have doubles, equal number of, like, questions basically like, are there 2x for every x in the array? Okay, this is the basic question. So what if we have, I'm gonna return true and ask for a query here. If I have 6 6 like that, this should return true. And if I have that, this should return false. Oh, it should be, oh, okay. Then okay, it should be, okay, this is 1. All right, and yeah, it cannot be like 2. 1 always corresponds to 1. So when I'm going over it like a 2-sum, if I just behave this like a 2-sum, I just create keys. I have 3, so I have 4. There is no, okay, 1 second. Okay, so for 4, let's say that I start from this bar, I have false. So what happens here is that, like, I don't have a corresponding double for this. I just represent that, or like I represent -1 here, and when I add 2 minus 2, it is basically again -2, because I don't have half of it or double of it. And then what happens is that I add 2, which has 4, so I just turn this to 4, I just turn this to 2, I have those. And then I add the others as well. And when we do this, we simply if I just turn this back to true. What if I have like 1 2 1 2 4 8, but in this order? Hmm. That's a problem. That is a problem. If I sort it, then I don't have that problem, right? If I sort it, I will not have that problem, and I will always have my double in the second later on. And here, if I sort it, I basically have it here 2, actually like -4. This is -1, and we check here, double of it is the previous. So I just turn this to true. I turn that 1 also to true, and I come here, just keep going on, and then yeah, I change them into something else. And for the second one, maybe I hold the count. I have 0 count. Actually, I have 1 corresponding and 1 corresponding. Here we have 0 corresponding, and then we have 4. And this is now becomes 0. This becomes 1. And what I want to, let's say that I have 2. This has corresponding. Actually, I see that there's 2. I check if there's extra 1 corresponding. If not, then we just append it here. We maybe do it like this. Yeah, if you count everything, yeah, and maybe instead of 4, I have now 6. So what happens here is I have 1 with 0, and this is also a problem. So if I just count everything, what if I have this, and then have like 2 and 6, I have 1 2 2 4, 1 2 2 4, for 6, 1 2 2 4. I want to turn this to 1, but this won't have corresponding. 6, 4, 5, 6, 4, 5, 6. Okay, this is for that. This is not 2. Come here, it is 0. It is 0. And for this, it is going to be the one that exists always should have more. Maybe I like, what if I have like this, like I have 1, create 1, it exists 1, and I have 2, I just delete this, and then the next one in the next time I have 2, I increase it like this, yeah, I have 1, maybe 1 more here, like 1 more here, which is like 3 here. I have 3 and I have 4, which makes it 2, and then 1, and then I now have 5, which is like that, 1, and then 6, which is 1. But what if I have this? It's basically -4, -2, okay, I think that works. So, okay. Is there any possible way? So, I'm gonna create a dictionary for every do I have to change anything for every item? No, I just need the item. Like value in array. If value is not in dictionary, we basically created 1, actually 0. I can turn this to default. It's fine. I create this deck, value is +1. I increase it. Not in the dictionary. If it is in the dictionary, I increase it. Actually, the first thing that I want to check is like if value divided by 2 is divided by 2 and like that is in the dictionary, or ×2 for negative numbers, ×2 is in the dictionary. If that's the case, I want to remove that, so decrease that, which is basically actually I want to check something. So from collections import counter, and then a is equal to counter like ABC, and then a dot a is equal to minus equal to 1, a, that, and then so if I check a in a, it says true. Oh, I have to remove it. Then okay, counter Python. I have to look at it. Where is it? Most common subtracts. Okay, I guess I have to deal with it. It's like I have to. So value times 2 minus 1 if dictionary value times 2 is equal to 0, then dictionary val 2, I want to delete it. So if that value is in there, I just stop. Else if similarly, this should be divide. Just divide it like that. We just check it. So if we don't have it, half of it and then double of it in the dictionary, in that case I basically want to value, it means that we have to add that value, and we check if it is not in the dictionary. Else if it is in the dictionary, I want to increase value by 1 and just make it 1. And at the end of this, everything, at the end of everything, I just check if, so return false if there's element in dictionary, if len dict is more than 1, else true. Okay, so print dictionary. This should be wait. Okay, now it works. Let's try other test cases. Okay, it looks like it's working. Maybe. Okay, let's talk about the complexity, time complexity here. So we have to store everything. So the space complexity can be space can be of n. The time complexity is again of n. I had to go over every one of it. Python dictionary delete key time complexity of 1. Okay. Yeah, I mean, I have pretty good memory and time complexity. Anything else? Oh, but here this is of n, but here this is just time is of n log n. So I'm curious if it is possible without if it is possible to have it without n log n. Yeah, I guess we have a problem there. It returns true, but because of the zeros. Uh, okay, so what can we do about zeros? Um, Actually, it's a bit tricky. Print dictionary. It returns 8 and 1. Oh yeah, it was the first case I told here. I guess I need that. Yeah, okay. I'm not sure if there's a way to do it without. Okay, this is n log n. Is there O of 1, O of n? Looks like there is none. Alright, so that's my answer to this problem. Array of double pairs.